Hello students, welcome to all of you. This is our third lecture on representation of geographical features. Prior to that, we discussed the topographical sheets, contours, contour interval or vertical interval, then horizontal equivalent, then identifying landforms with the help of contours that we discussed. Then a bit of type of slopes I told you about. So now today we will discuss the types of slopes and what type of contours are used for a typical landform. So the slopes can be broadly classified into gentle, steep, concave, convex and irregular or undulating. The contours are of different types of slopes show a distinct spacing pattern. So first is the gentle slope. When the degree or angle of slope or a feature is very low, the slope will be gentle. The contours representing this type of slope are far apart. One more thing I want to tell you that like here I am discussing some definitions with you, like there is a definition of gentle slope, steep slope and so on. I will be coming later also. You can note down these definitions along with the type of contour that can be drawn for a particular type of landform. This is what you will be doing when I will ask you to do in the homework part and all. So till then just understand this concept. So this is a gentle slope, the definition of gentle slope and how it looks like. This looks like this. You can very well see that the slope is very gentle, very low angle of slope is there. This type of slope is called a gentle slope, and what type of contours we use for this is just like this. Almost equally spaced contours are used where the central portion is showing the height and the outer portion are showing the slope. Like here, from here the slope is increasing, from here the number of the contours are increasing. So this is how we will be drawing for a gentle slope. The reverse will be happening in the steep slope, in the sense that the contours will be closely spaced and the height, just like the gentle slope, will be more in the central part. Like here you can see 700, the maximum height is there for the central portion. So here's the definition. When the degree or angle of slope is high and contours are closely spaced, they indicate the steep slope. So whenever you will encounter this kind of contours in the topo sheet, you will understand that this is showing a steep slope, whereas this type of contours are showing a gentle slope. I'm sorry, it got repeated. Please ignore. Next is the concave and convex slope. So concave slope is a slope with gentle gradient in the lower parts of a relief feature and steep in its upper parts. Contours in this type of slope are widely spaced in the lower parts and are closely spaced in the upper parts. Like here you can see the concave slope, widely spaced in the lower part. For the lower part, since it is a gentle slope here, so here the contours will be widely spaced, whereas here they are being more in a compact form, since we are having some kind of steep slope here. This is the convex slope. The shape of the convex slope is like this, you know that, and how we will be showing it with the contours. This is the pattern. Widely spaced towards the top and closely spaced towards the bottom. Here's the definition. Unlike concave slope, the convex slope is fairly gentle in the upper part and steep in the lower part. Next is a conical hill and plateau. This I told you in the earlier class also. Conical hill. Here is the conical hill and how we will be showing it with contours. The center of the slope, apex of this hill, will be shown here, and the rest of the things will be shown like this. Here is a plateau which is shown with the broader contours. And you can here also notice that the highest portions are shown with the highest numbers of the contours. Here also the highest part of the plateau, which is this, is shown with the highest number of contour, 1500 for the central part, here 2200 for the central part. So whenever we show height, this is an elevated part. You know that conical slope or plateau is an elevated part which is comparatively higher to the land. So these features always will be shown with the higher central portion, whereas the reverse will be happening for the depressions. Next is the V-shaped valley and U-shaped valley. A V-shaped valley occurs in mountainous areas. The lowermost part of V-shaped valley is shown by the innermost contour line with very small gap between its two sides, and the lowest value of the contour is assigned to it. The contour value increases with uniform intervals for all other contour lines outward. Now let's see what type of contour it will be having. It is like this. So since this is a depression, I told you in the depression the central part is shown with the lower number of contours, like 900. Then it is increasing outward as we are moving from the center of the valley towards the outer portions. This is increasing for these. Whereas in the U-shaped valley, just go through the definition first. A U-shaped valley is formed by strong lateral erosion of glaciers at high altitudes. The flat white bottom and steep sides makes it resemble the letter U. The lowermost part is shown by the innermost contour line with a wide gap between two sides. Here is the central part, which is the depressed portion. This will be shown by the lower numbers, whereas the outer portion, like that of the V-shaped valley, outer portion will be shown by the higher numbers of contours, like here 4000, and it is decreasing in the depression. Whereas in the elevated portion, like that of the conical hill and plateau, the things were reversed. Like the central part was having the maximum numbers and the outer parts were having the least of the numbers. So here is a gorge. A gorge is represented by very closely spaced contour lines on a map, with the innermost contour showing small gap between its two sides. Here a gorge is there, and how the contour will be drawn. You can see it is increasing outwards, like here. Since the gorge is a depressed landform, it is a depression kind of landform. And spur, since it is an elevated thing, like here there is a definition: a tongue of land projecting from higher ground into the lower is called a spur. The arms of the V point to the higher ground and the apex of V to the lower ones. So how it is shown? A spur is shown like this. So the contour for spur will be having maximum contour height over here in the center. It will be, the center is represented by this contour, it is having the maximum number, whereas the rest ones are having lesser number, since it is getting reduced. The height is getting reduced here, and it is being shown by this reduction in number of the contours. This is what we can decipher by the contours. So in this way you got to know how the contours represent the 3D landforms in a topographical map. There is a cliff. It is a very steep or almost perpendicular face of landform, and how we show that? This is a cliff. Actual cliff is like this, and these will be the contours for the cliff. Central portion, which is the higher one, is shown by this, the contour having the maximum number, and the rest will be reducing. And if you notice that these contours are getting compacted here and kind of joining at this point, which is having a rapid accumulation of all these contours over here. Next is the waterfall. A sudden and more or less perpendicular descent of water from a considerable height It is called waterfall. The contours representing a waterfall merge into one another while crossing a river stream, and the rapids are shown by relatively distant contour lines on a map. This is how we show a waterfall. So this is it for today. This is sufficient for you, I think. Just go through it. Just notice the type of contours used for a specific type of landform. We'll be covering the upcoming topics in the next topic, next lecture. Till then, take care. Thank you.